Hey everybody, welcome back. So just a little quickie here today. I had the driver's rear window on my 98 Jeep Grand Cherokee drop into the door and not roll up. So in preceding years, I have fixed the other three regulators so I know exactly what's going on. And let me show you real quick. There's these little knobs, and you see one here, and they've got a plastic ring on them. And that plastic ring, if I can pop it back on there, that plastic ring, this is only half of one, it broke in half, that's the problem, fits inside these channels like that. And then the scissor mechanism, and you can see there's still one intact, you can kind of see it in there, that lets the window scissor up and down. So those little plastic parts break in half and the window drops in the door. And how I typically repaired them in the past was these little shower door rollers. Well, they come four to a pack, and I used three in the last pack, and I only have one left, and none of the local hardware stores carry them anymore. I guess it's for something that's just too old, they don't sell them anymore. I could still buy them on Amazon, but you know what? We have a 3D printer, so let's use the thing. So I designed a part, and here is one of my early trials of it. I made this out of the clear ABS, and I heated it and popped it over there, and honestly, I think it's going to work really well. I tweaked it a little bit more, but I think that's going to work really well for us. So, and I'm using the new phone, the Blue Vivo XI this morning to film this. So, yeah, I hope that works out really good for us. So, let's get back to my computer in Fusion and let me show you the part I made. And we'll talk about it for a second, and I'll print some more out, and we'll see if we can fix this thing. Be right back. Okay, so here's the little part I made. As you can see, it is pretty much very similar to the part that broke off of it. And what it is it's kind of concave in here and convex out here. I got that right, didn't I? Concave and convex, I think so. And one of the things you'll notice on it is this little projection is there to keep that steel ball from moving in that direction. Because I think how they assembled this is that taper on this side of that steel ball is much more gradual than it is out here on this end. And I think what they did is they assembled that little steel ball pin into this while it was still two pieces, and then they riveted the assembly to the scissor arm. I don't really want to grind those off and re-weld them back on. I mean, I could, but I'm going to try it this way first. So what I've done is, you can see this little lip here. What I've done is I have made this part enough bigger that it will go over without this breaking, but it will still give me the function of this spacer preventing that steel pin from moving through in that direction. And I've got some ideas on how. I don't really think I need to do anything on the outside, but I could if I think I need to, but I really don't. So let's take a look at how I made this thing. Let's open up this original sketch. And this thing, and I'm still not used to this new UI in Fusion 360, so I'm a little slower on it than I was when the previous one. So this is what I did. I just came in and I just free-handed this, and then as I started fooling with it, I started throwing dimensions at it. This is not parametric in any way, shape, or form. Like I say, I just started throwing things in it. Then what I did is I used the revolve command to revolve it back into a circle. And if we end this sketch, you can see, if I highlight the sketch here, you can see the original part there, and then I just hit revolve, and it revolved that all the way around into a 3D part. And then I started using the measurement tool, and I started trying to measure it to make sure I got kind of sort of the original measurements, and this thing prints in 8 minutes, so I didn't really see any need to do any more than that. I just started printing them, and really I only had to print 3 before I found one I liked. Now, the reason I'm doing this in the ABS and not the nylon is because the clear ABS happens to be on the printer as it is, the enclosed Ender 3, and yeah, I've had very good luck with ABS. It seems like it's really tough material, so I'm going to go with the ABS for this. That window mechanism on that vehicle, especially the rear doors, takes me about 10-15 minutes to pop it out. So if I have to go back and do it again, it's not the end of my world. And you can get the window to roll up even with all those things breaking just by kind of putting some pressure on the window to angle the bottom and then bringing the mechanism up. You can catch those steel pins on the bottom and then hold it in that position while it rolls up. So I'm going to go with this, and we're going to see how well this works compared to shower door rollers. So let me show you the printed parts I've got done. I know they're tiny, but I'll see if I can't get a decent view of them, and then we'll go back out and we'll put it back together. Be right back. All right, so here is the little part, and I am on my phone again just because this is a quickie and I'm lazy and don't want to set the lights and everything up. When there was a pronounced Z-seam on these, I filed them down to make it smooth, and this is what we are going to try, what I am going to try to use to repair that. Stuff is really tough. I took an earlier one and I squeezed it with pliers, and stuff is really tough. So I printed these with my typical ABS Cura profile and with 50% infill. And let's go out in the garage and let's put these on and let's see if they'll work for us. Okay, here we are back again. Now there's a couple different ways I could do this. First and foremost, I could do it the way I did my little test piece. I could heat these up, put these on there, and then use my channel locks to squeeze it over and then attempt to put it in the channel. Or I can slide them into the channel first and heat them and then attempt to squeeze the pins into it. And I believe this latter method is what I'm going to try. I may regret it, but you know what? I can always print more of them if I wreck them. And it's like I say, it's not a hard regulator to get out. So I'm going to pause, going to do that, and going to be right back. Okay, I've got this thing all back together. All 4 parts are on it. Everything's greased up, slides pretty easy. Got a little bit of movement that way as the balls move inside that the plastic pieces, but there's very little up and down. I even did this one here too. This damn thing is incredibly awkward. Every time you try and pick it up or turn it, it tries to scissors closed on your fingers. But you can see, maybe you can see, can't see, I got a new one in there too that I made, and can't really see it. The new one's in there that I made. So going to get this thing put back in and we'll put it to the test and see if it works and see how long it lasts. Be right back. Okay, here we go. It's all back together. Getting kind of late in the day here. It could use some adjustment, but I want to get back inside. So there we go. Fix the 3D printed parts. Let's hope it holds up. Thanks for watching, guys. Catch you later, and don't forget to like and subscribe and hit notifications. Have a great one. Bye for now.